All right. Hello, everyone. My name is Aviral Srivastava, and I am here representing my team, Lablas Strikers. And this is our presentation to qualify for Smart India Hackathon 2024. So the problem statement that we are going with is developing a tire maintenance and operation app, including fitment of necessary IIoT-related hardware in Dumpers. The theme of this problem statement is of smart automation, and it falls under the category of hardware. So looking at our proposed solution, we'll be developing a comprehensive system for monitoring and managing tires on high capacity dumpers that are used in mining operation. So what these dumpers basically are is these are huge truck or huge machine that are used to carry out the payload that the coal out of these mines. And these dumpers, they consist of these huge tires. They can stretch up to a height of 6 feet, and they can, and these tires can cost up to uh, 25 lakh each. And when you hear that they are so expensive, that you do realize that there is a need for managing these tires better and making sure that their lifespan gets better. And that's what our system is going to be doing. On your left, you can see a whole flowchart of a whole overview of what our project is going to be like. I'll get into it, but first let's discuss the key components. So, starting with the first one, what is TKPH assessment? So, TKPH, well, first, let me get something clear. Each tire that is on these dumper, they come up with a TKPH value, their designated TKPH value. And this TKPH value is basically nothing. It tells us how much load can be, you know, can be covered by this tire over a specific speed. And what our system is going to be doing, or what it needs to do, is in real time, it needs to calculate the TKPH value of our tires in that very instant. And how it's going to do that is using a formula. It's taking the mean load of taking the mean load that is on the tires and multiplying it with the average speed during the shift. And here we have the current TKPH value that our system has calculated. Here we have the designated TKPH value that the tire comes up with. We're going to compare it, and if it's a higher or if it's a low something, then we're going to send down an notification down our application that there needs to be some adjustments done to the tire, and maybe the person need to change the tire all in all. Then I forgot to tell you why we do need to do that. So you can think of that TKPH is something that we need to keep in mind, because having a correct TKPH value determines whether your tire is gonna overheat or not. And we don't want to do that. We have to have the correct TKPH value so that our tire won't overheat. So with that, I want to move on to tire pressure monitoring. So we have these IoT sensors that are getting us the data, pressure, temperature, load data, and we are getting this real-time pressure of each tire. And again, we are doing the same. We're getting the real-time data, the real-time pressure data that we have on these tires, comparing it with what the pressure should be, and if it is higher, it is low. Again, sending down a notification down the application, and yeah, that's pretty much it. Making sure that not because of low or high pressure, some accidents can occur. And then there's tire performance analysis. Basically, it's taking all the historical data that we can get our hands on, the historical data that tells us what is the average lifespan of a tire in a specific mining condition, what is the failure data, like how many times it has failed, in what circumstances it has failed, and taking all that data and then uh, developing and training a machine learning model to get a analysis sheet of how a tire is going to perform in this mining situation. And the last but not the least, we have the vision-based tire conditionment. This would be also done by machine learning. So basically, what we will do is for each tire, we'll be implementing maybe one or two cameras that's going to be taking high resolution pictures of the tire or the surface of the tire. And then we'll be looking into, we'll be developing and again training a model to look at those pictures and, determine how much wear and tear has happened and determine if the wear and tear has exceeded to such an extent that there is a need to take this to the repair shop. And yeah, that's pretty much it. I think how it addresses the problem. I think I already told you that we're optimizing tire selection based on DKP assessment, reducing downtime through real-time tire pressure monitoring. Just saves time, when you get to look at your phone and see how much pressure is it in those tires. Enhancing tire life to data-driven performance analysis, identifying tire wear and damage early with precision-based monitoring. And here is our innovative model that just gives you an overview what our whole project is. Okay, so I think we should move on. Okay, what technical approach we would be taking? Well, first and foremost, we'll be collecting data using IoT sensors and cameras. Then we'll be putting it in the processing, implementing machine learning models for DKPH assessment, tire condition monitoring using cameras and the historic data that I told you about. Then after all that processing, filtering out the data and tunneling into the user interface in the mobile apps and the web dashboard. So, so the programming languages, the languages that we'll be using is Python to write algorithms, JavaScript to do server-side scripting, frameworks. You'll be using TensorFlow for machine learning, React for web dashboard, and React Native for building the mobile application, Flask for Django for backend, and in hardware we got the IoT sensors and high resolution cameras. So yeah, everything is covered also in here. So let's move on. So let's talk about why this project is feasible and viable. Well, what makes this project technologically feasible is that we are using proven technologies. We are not developing something new. We are using IoT sensors. We are using machine learning algorithms and computer vision, and just putting them all together cater to this specific problem. Then there's economic feasibility. We are lowering operational costs by reducing the tire's life cycle, and then the cost of hardware, that is the sensors and cameras, would be covered by the long-term savings that this project is going to help us do. And there's increased productivity of developers due to better tire management, early damage detection, say camera vision. Yeah, let's look at what makes this project viable. But first and foremost, there is a demand for this. Mining operations is it's a very niche market. Even though it's a niche market, there is a need for such solution, for such innovative solution, and there's a demand for it. So why not build it? Scalability, it can be easily deployed across multiple numbers and mining location. Once the server side is set up, I think then all it comes down to is going to places, putting all the hardware on the dumpers, connecting it to the clouds. Then there is cost benefit. So there's a strong ROI by maximizing downtime, optimizing tires usage. There would just be a potential partnership in this. Either we can partnership with the company that manufactures these dumpers and tires, and we can ask them to, hey, why not put this system, why not put this hardware into the manufacturing unit while we're doing it? And there we have it, potential partnership. Then there's sustainability. It's environmentally friendly because we are reducing tire waste. Now let's look at the challenges. And first and foremost is data accuracy. It's a very harsh situation. These mining operation occur in a very harsh condition. So for that, we got to use industrial grade sensors to make sure they don't stop working. Then there's the connectivity issue. What could happen in these areas, in these mines, is could be a loss of network. So what we can do is we can set up a data storage unit on that very place and synchronize it when the connectivity does come on to the cloud. And keep doing it whenever we do get connection. It it doesn't really solve the problem on its own, but we are making progress in it. Then there's hardware durability as a doctor. So we would be using industrial grade sensors. Then there's user adoption. On our end, we try to make the user interface as friendly as possible, but still maybe it's a new it's a new day and age, and we can I don't know, create a user guide to understand all understand the working of this project and give them that guide. Okay. Moving on, we have impacts and benefits. So the first impact is the operation efficiency just goes up. Productivity goes up, downtime goes down, and we are making timely decision based on data. It's a good thing. Then there is safety. We are doing real-time monitoring. We are giving alerts whenever there is a need to change or adjust the tire, maybe because of TKPH assessment or maybe because of tire pressure, and that just reduces the accidents that could occur because of these tires. Then there is cost. Okay, obviously we're trying to increase the tire life cycle. So that means the frequency of replacement of these tires would go down. So that's a good thing. And then the whole operational expenses would be significantly reduced. Then looking at the innovative part of it, we'll be using IoT, machine learning, and we'll be completely digitizing this whole niche. So that also packs and pack. Looking at the benefits, we have economic benefits. Maintenance cost goes down, replacement cost goes down, the resources are utilized much more efficiently. People don't have to worry, when the tire is gonna get on a low pressure, and whether it's perfect, not perfect, but in line with the TKPH assessment or not. And then this environmental factor, we are reducing tire waste, sustainability, and there's efficient use, social safety standards are going up, accident risks are going down. I think, yeah, we got everything covered in here, and I think that's almost the end of it. Yeah. So with that, I guess I want to conclude my presentation, and I want to thank you for bearing with me and watching till the last. And I hope we do get qualified. Thank you.